In this video, we're going to continue our conversation about significant figures and focus on what is and isn't a significant figure when reading a number. So when we report a value, we'll report all of the numbers that we measure on an instrument plus an estimated digit. But let's say we're reading a value that someone measured. We're going to want to be able to determine how many significant figures they're reporting. And so to do this, we're going to need to go through a few rules about what makes a digit significant or non-significant when you're reading it. So first, we're going to look at non-zero numbers. So all of them that are reported will be a significant figure. If it isn't zero, it's a sig fig. The zeros are where it gets tricky. So if a zero will be a significant figure, let's put it that way, when it's either between two non-zero digits. So an example of this would be 303. That zero is significant. Or if it's at the end of a number with a decimal place. And so an example of this might be 33.0. Because there's a decimal place, it communicates that that zero is a sig fig or a significant figure. Now, it will not count as a sig fig. So a zero is not a significant figure when it's at the beginning of a number. So let's say it's something like 0.0033. Now, there's a decimal place, but these zeros are at the beginning before my non-zero number. So since it's before a non-zero and not after, it's not a sig fig. This also occurs, it's not a significant figure when it's at the end of a number without a decimal place. So if instead of 33.0 we had 330, this zero would not be a significant figure. In both of these cases, the zero is acting as a placeholder. And when zeros are acting as a placeholder, it's just giving a scope of magnitude. It's not actually giving us any information about how the measurement was made. So after decimal places or when or before a decimal place, as long as it's there, as long as it's after a non-zero number, it'll be a significant figure. So we can look at a few examples of these right here. There we go. So in the case of 500, we have trailing zeros without a decimal place. And so the only significant figure in the number 500 here as written is there's just one. Now I could change this. If I had written this as 500 decimal place and nothing else, then all three of these numbers would become significant because that decimal place was added. And now this would be 3 sig figs. Now in our next one, we have a zero, but it's in between two non-zero numbers, the 5 and the 1. So that means this will be a 3 significant figure number. That zero counts as a sig fig. Now we have a combination of these two. We have zero that is sandwiched in between two non-zero numbers. But then we also have two trailing zeros without a decimal place. So only that zero that's in between the 5 and the 1 is a significant figure. And we have 3 sig figs for the number 500,100. Let's look at some examples with decimals now. So here we have a decimal place. And so because of that decimal place, all of our zeros after a non-zero number will become significant. And so we start with a non-zero number, this 5. That makes everything after it a significant figure. And so we have 4 significant figures. The 5 counts and all 3 of our zeros, including the one after the decimal place. Now, moving down, we have a decimal place again, and this time our first number is a 0. And a 0 is only significant following a non-zero number. So I'm going to go to my first non-zero number, which is this 5 right here. Now, because I have a decimal place, the zeros that follow that 5 will be significant. And this one happens to be sandwiched in between a 5 and a 1, so I definitely know that one's significant. The 2 preceding zeros are just placeholders. So this would be 3 significant figures. Now let's get rid of that 1. So we have a non-zero number. So anything before that non-zero number is just a placeholder. And after it, I have 2 zeros. But because they come after a non-zero number and there's a decimal place, they are significant figures. So I'll have 3 significant figures for the number 0.0500. Let's continue with some of our rules. And these ones are about how we manipulate a number through algebra. And so we're going to look at what happens when you apply multiplication, division, addition, or subtraction to a number that is measured. And how do we continue to communicate that level of precision in the instrument as we manipulate the number mathematically? So in general, there's just 2 rules. One is going to apply to multiplication and division operations, and one will apply to addition and subtraction operations. So you'll follow these in the order of operations that the calculation would be performed. The rule for multiplication and division is that your answer will need to have the same number of significant figures as the original number that had the fewest significant figures. So if in this example I had 3 numbers that were being multiplied, and we're going to need to assume here that these are all inexact numbers, that they all have sig figs. Then the value I get when I plug this into my calculator is this big long number right here, 6.7208. I'll report the number of significant figures that matches the least significant figures within the 3 numbers that are calculated or multiplied together. And that's this 0.53. It has 2 significant figures. So I'll round my number to 2 significant figures when I report it. And the idea here is that we are going to always report with the least amount of certainty that we have from the instruments that we used. So the same thing happens with division. If I have 2 numbers that are both inexact as well, so I have 2.0035 with 5 significant figures and 3.20 with 3 significant figures. When I plug this into my calculator and I get a nice long decimal number, I will round this to the least sig figs that went into the calculation, which is that 3 significant figures. So I'm going to round it to 3 significant figures, or 0.626. Most of the conversions and the calculations you will be doing in chemistry will be multiplication and division. So you will use this rule the most. Unfortunately, the addition and subtraction rule is not the same. And so it's really easy to accidentally apply the multiplication and division rule to all mathematical operations. But when we do addition and subtraction, we have to, instead of reporting the least significant figures, we need to report the least number of decimal places. And so if I have 3 numbers, let's give this a little bit more room. I have 3 numbers that I am going to be, let's say, adding together. I think we lost our addition sign. I am going to go ahead and add them up like I normally would, get one large number here, and then I'm going to go ahead and report to the least number of decimal places, which is this 0.07. And so I'll do 2 decimal places, and that'll give me 5.41. And now this is 3 significant figures if I look at this and apply that to a later calculation, which doesn't match the number of significant figures of any of my numbers that went into the calculation. But these 2 decimal places match the 2 decimal places of 0.07. I'll do the same thing when I do subtraction. This 5.9 number here has the least number of decimal places. It has only 1. So I'm going to report my answer to just 1 decimal place as well, and I'll have a value that's 5.7. Here I'm rounding up that 5.679. When I cut off my last 2 digits, so I have 1 decimal place, I'm cutting off a number that's greater than 5, and so I'll round up to that 5.7 rather than 5.6. Let's talk more about those rules for rounding. So hopefully this is somewhat intuitive. So when we are going to round to the correct number of significant figures, we oftentimes are going to also have to manage whether or not we round up or round down. So we're going to round down if the last digit is a 4 or less. And we're going to round up when the digit is a 5 or more. And so in this case here, if I need to round to two significant figures, I am going to keep this 63. But my first digit that's dropped is an 8, which is greater than 5. So I'll round this whole number up to 64 when I report it to two significant figures. In general, it's important to only round at the end of your calculation. Sometimes you'll get a pretty similar answer if you round at each step. But sometimes, especially when we're using very large or very small numbers, rounding at each step can give us a dramatically different number, well outside a range of tolerance for it being similar. So especially when doing homework assignments on Sapling or when expecting me to follow your work, it's important to do the calculation and round at the end in multi-step calculation so that way we get close to the same value. And that means you're going to need to keep track of your sig figs because we apply our significant figure rules after each mathematical operation because sometimes they're addition and sometimes they're subtraction and sometimes they're multiplication or division. And so unless everything is multiplication or division, like in many conversion problems, then you're going to need to have a way of keeping track of what significant figures you have while still keeping all of your digits and rounding at the end. And the method that I like to use for this is underlining. So I like underlining the significant digit in my answer and then keeping all of the trailing digits that follow it. So that way I can look back and say, oh, well, when I finished the first step of my calculation, I had only two significant figures. I then performed a multiplication operation with something with four significant figures. So my answer should now be 2 again, but I've still been able to keep all my digits moving forward. And oftentimes we're just plugging this into our calculator as we go. And so keeping track at each step usually means slowing our process down, which is really frustrating to do when we're learning this. And you'll get faster at it and faster at it. But in the beginning, it's best to slow down and go stepwise and make sure you're using the correct rules for significant figures at each of those steps and underlining it to keep track of it.